Welcome all. Today we start another module, that is module number 3, aromatic hydrocarbons. This module mainly focus on the IUPAC nomenclature of aromatic compounds, structure and stability of benzene, the most important member of the class, and then about the mechanism of the most important chemical reaction which aromatic hydrocarbons undergo, that is electrophilic aromatic substitution reactions. And finally, we have to discuss about the concept of aromaticity. Historically, aromatic compounds got its name from the Greek word aroma, which means characteristic smell, fragrance. So it was thought that aromatic compounds are characterized by their special smell or fragrance, but later in modern organic chemistry it is proved that the speciality of aromatic compounds, aromatic hydrocarbons or aromatic compounds, are not their characteristic smell but the special stability associated with them. The history of aromatic hydrocarbons started in 1825 with Michael Faraday's discovery of the first aromatic compound, that is benzene. He isolated benzene from whale oil and he named benzene as bicarburet of hydrogen. Later in 1834, Mitscherlich synthesized benzene by heating benzoic acid with calcium oxide. He also determined the molecular formula as C6H6. In this session, we discuss about IUPAC nomenclature. Unlike aliphatic compounds, the IUPAC nomenclature of aromatic compound is a little bit flexible, such that the same compound can have more than one IUPAC accepted name. First of all, we discuss monosubstituted benzene. Formerly, benzene was called pheno, and so the aryl group originated from benzene is called phenyl. In monosubstituted benzene, IUPAC rule is to prefix the substituent to the name benzene. IUPAC also accepted certain special name for certain functional groups. Let's take examples now. Here, the first one, you can see Cl is the substituent, Cl. So we call it chlorobenzene. We fix chloro as the prefix. So chlorobenzene. Next is bromobenzene, nitrobenzene, ethylbenzene. See, in cyclic compound, if there is only one substituent or functional group, we need not mention any position. Position comes only when there are more than one substituent. Let's go to next examples, more examples. Here, The substituent is methyl group, so we can call it methyl benzene as a strict IUPAC name, but IUPAC is accepted a single special name for this, that is toluene. This is hydroxybenzene or phenol, aminobenzene or aniline, benzene carbaldehyde or benzaldehyde, benzene carboxylic acid or benzoic acid. This is methoxy group, so methoxybenzene or IUPAC special name is anisole. This is vinyl benzene, or it can be singly called styrene. This is cyanobenzene, or it has another IUPAC name, that is benzonitrile. Now we go on to the disubstituted benzene, where there are two substituents. First of all, let us consider the case where both substituents are the same. Here you can see there are two chlorine. Here comes what is called position isomerism. How many position isomers are possible for a disubstituted benzene? Obviously 3. That is, if the two substituents are on the adjacent carbons, there is 1,2 position. So what is the name? It can be called 1,2 dichlorobenzene. 1,2 dichlorobenzene. Now this 1,2 position is commonly called ortho position. So another name is ortho dichlorobenzene, which is the trivial name. IUPAC strictly follow position in terms of number. So IUPAC name is only 1,2 dichlorobenzene. The next position isomer is, we change the position to 1 and 3. This is 1 and this is 3. So 1,3 dichlorobenzene, or commonly called meta dichlorobenzene. Then the position, the next isomer is 1,4. The carbon atoms in the ring can be numbered 1 and 4. So 1,4 dichlorobenzene, or it is commonly called para-dichlorobenzene. Now we take examples where the substituents are different. Here what is the rule? Priority is given in alphabetical order. So we give lower number for the substituent having greater alphabetical order, and the remaining substituent is given the lowest possible number as you number the ring clockwise or anti-clockwise. Suppose there is a substituent giving special name or single name to benzene, that is given priority and given position 1. Let's take examples. In the first one, you have chloro and nitro group. Neither of the groups gives special name, so we consider only alphabetical priority. So chloro comes first. So the carbon carrying chlorine is given position 1. So the nitro group get position 2. So the name will be 1-chloro-2-nitrobenzene. Always when you write the name, strictly follow alphabetical priority. The next one, you have bromo and iodo groups. Neither group gives special name. So priority is for bromo alphabetically. So 1 bromo, 3 iodo benzene. Okay. Then since these are meta positions to each other, you can also use as a trivial name meta bromo iodobenzene. The next is, you have chloro and ethyl. Alphabetically chloro comes first, so position 1, and this is 4. So 1-chloro 4-ethyl benzene or para-chloroethyl benzene. Now taking next examples where one of these substituent has can give special name to benzene. So here priority is given for that group which gives special name to benzene. In the first example, NH2 and Br. You know that NH2 with benzene get the name aniline. So NH2 get priority, so it is position 1 and bromine get position 4. So what's the name? 4-bromo-aniline. So this one, position 1 need not be mentioned here because when you say aniline, it is that NH2 is given position 1. With respect to that, bromine get position 4. So 4-bromo-aniline or para-bromo-aniline. In the next one, OH gives special name to benzene. So the name is phenol, so that OH get position 1 and NO2 get position 3 in clockwise numbering. So when you number a ring, there are two options, clockwise or anti-clockwise. Number in such a way that the other substituent gets lower number. So what's the name? 3-nitrophenol or metanitrophenol. In the next one, it is COH giving special name. So it is benzoic acid with position 1 for COH and position 2 for chlorine. So 2-chlorobenzoic acid or orthochlorobenzoic acid. In the next one, it is both CH3 groups. In such cases, there are special names. They are called xylene. Strict IUP's name is dimethylbenzene. If you prefix it, position is 1, 4. So you can call strictly as 1,4 dichlorobenzene or 1,4-xylene, also called paraxylene. The point here is, in some cases when there are two substituents which are same or different, there are some special names like dimethylbenzene is also called xylene. Here the next one, OH and CH3. With OH it is phenol, with CH3 it is toluene, right? But together it is called cresol. If benzene is having one OH and one CH3, there is a single name that's called cresol and the position is meta to each other. So metacresol. You can give other names like if this is phenol, position 1 for OH, then this is 3 for methyl. So you can also call this 3-methyl phenol. In the next one, it is CH3 giving toluene, NH2 giving aniline. Together it is called toluidine. Toluene plus aniline together, toluidine. And position is ortho to each other. So orthotoluidine. You can also name it as, if this is aniline with position 1 for NH2, then 2 for methyl. So what is the name? 2-methyl aniline. That's also correct. Now finally we go to polysubstituted benzene where there are more than 2. Here the rule is that you just give the priority for the lowest position for the substituents, right? Just you number such that lowest positions are obtained for various substituents. That is the priority given here. So here nitro group, chloro and ethyl is there. Don't take the alphabetical priority, you just give the lowest number for substituents. So it is better to start from nitro, that is position 1 here, 2 here and 4 here. You cannot start from chloro giving alphabetical priority 1 and then other groups will be getting larger number. So that is avoided. Now writing the name is always in alphabetical order. So what is the name? 2-chloro, 4-ethyl, 1-nitrobenzene. In the next one, bromo, iodo, chloro. Don't consider the alphabetical priority and give bromine 1. Then iodine and chlorine will be getting 3 and 4. That's the larger numbers. Instead, we start numbering from chlorine given 1, 2, and 4 like this. So it is 1 to 4. That is the lowest number possible for the substituents, but writing in alphabetical order. So what is the name? 4 bromo, 1 chloro, 2 iodobenzene. The next one, numbering starting from bromine, 1, 2, 4, alphabetical order, 1 bromo, 4 chloro, 2 nitrobenzene. Right? So this is how we do it for polysubstituted benzene. Now finally, what is the speciality here? Here there are groups giving special name to benzene. In that case, in polysubstituted benzene, if there is a special group giving special name, single name to benzene, then that is given position 1, and then number the rest of the substituents clockwise or anti-clockwise such that lowest number is given for remaining substituents. So here with CH3 we get the name toluene, so position 1 for CH3. Then go clockwise, so 2 for chloro, 4 for nitro. So what is the name? 2 chloro, 4 nitro toluene. The next one you can see this OH is giving special name. So position 1 for OH, 2 for chlorine, 4 for bromo. So what's the name? 4 bromo 2 chlorophenol. In the next one you can see NH2 giving special name. So position 1 for NH2, 2 and 4, 2 chloro 4 nitro aniline. Hope it's clear to you. Practice more examples. Thank you.